So with that, I'll introduce our speaker. Ben Peierls is the research director at Lakes Environmental Association. He runs the Main Lake Science Center. Ben and his brother maintain a camp on Sand Pond in Denmark, where they spent many summers as young kids. Since he got his bachelor's degree from Cornell University 30 years ago, he's been actively involved as a technician, graduate student, postdoc researcher in aquatic ecosystem research, including studies of lakes, large rivers, and estuaries. He focuses on phytoplankton, microbial ecology, and general water quality issues such as eutrophication. Ben received an MS and a PhD in marine sciences from the University of North Carolina at Chapel Hill and was involved in the fieldwork and data management for several long-term estuarine monitoring projects. When not studying aquatic systems, he enjoys sailing on and swimming in them, as well as playing ultimate and performing music. We're very happy to have him back. He was a great speaker last year. He's always a great speaker, and we're very happy to have him back this year for a talk entitled Winter Lake Monitoring, Life in Limnology Under the Ice. So Ben, I think I see you there. I will stop my slides.
There you go.
It's all yours.
Okay, let me share my screen. Do a little check of our controls, sharing the sound. Okay. Can you see that all right?
Yeah.
Okay. I don't know if this little box will be in the way, but all right. Well, what a humbling introduction. Thank you, Susan, and thanks for everyone showing up. I guess the snow is going to be very attractive, I think, for a lot of folks around here for skiing. So, but I know I'm a little bit tired from shoveling. I'm glad for a little bit of a break. So I'm happy to be with you here today, and I'm going to try to move to my next slide. And I'm just going to play a little clip of something just to kind of set the mood. Hopefully you can hear that. I did say multimedia, so I thought some sounds of the frozen lake would be interesting for you. Lakes in the winter are pretty harsh conditions. This kind of demonstrates that. So, and from looking at a lake from up high, this is a drone image, courtesy of a member on Woods Pond. Lakes appear to be dormant in the winter, and at least that, and you know, the sounds of the ice, everything is frozen and cold and quiet. But you know, there's a lot of activity on the lake, on a frozen lake in winter. Ice fishermen are out. It's a very popular and big business. So they must know something. There's something going on. The fish are there. They need a food source. So what's happening? This was actually on our sand pond, and that's a cup. It seems like we maybe have a bit of a hole in our understanding of lake ecosystems when it comes to observations and measurements during the winter time or under ice periods. Part of the reason for that is that part of the reason that winter time has been understudied is because of those preconception notions. It's a dormant season, an insignificant season. And historically, we've mostly focused on the summertime growing seasons. And part of that's also due to technological difficulties. It's cold, it's dangerous. And it's also during a time when a lot of university folks are in class and busy. So not a lot has been done. However, more recently, people are starting to take note of and record the fact that ice cover, duration of ice cover on lakes is changing, it's decreasing. This is a figure from Hodgkins et al. That shows the ice out date. That's when ice melts and breaks up for a bunch of lakes in New England, especially several main lakes as well that I'm sure you recognize. And that's been the date of that ice out has been decreasing over time. And that's pretty clearly connected to global warming. So another thing that's happened because of that noticing of change going on is that the number of publications dealing with lake ice and wintertime issues has increased. This was on the left as a figure of the number of publications produced by year with those looking at Web of Science search terms of lake ice and winter, not sea. So I didn't get sea ice. There was even a very specific conference that was held in fall of 2019 called Winter Limnology in a Changing World. And that's pretty amazing. So the interest has really grown. And with all that work, that despite all those preconceptions about being fairly dormant, it's been shown that really it isn't. There's not as static as often supposed. These are quotes from various publications, and that dormancy and decomposition are not the only thing going on. And it's a very dynamic and potentially important in terms of ecosystem understanding for lakes. Still, it's clear that there's a lot to learn. And for us here at LEA, there are not many examples, or local examples of winter conditions for our lakes. So we took it upon ourselves to try to be good scientists and go out and observe the conditions for ourselves. And so that's what I wanted to do today, is to give you a bit of an update on the work that we've done over the last 3 years. And we're starting into a 4th year of winter lake monitoring, give you an idea of when we went and where we went and how we did it and what did we find. So for winter lake monitoring, the when is pretty obvious. It's winter, but more specifically, we go when the ice is safe. So this is not when we go out. And we thought it'd be fun just to kind of play around. We have a poll that's going to come up now. And if you take just a couple of minutes and let's just see what people think about when is it safe. I'll read it out. What is the minimum thickness of ice needed in order to walk safely on it? So go ahead and fill those in if you can. How long should we give them? Is that it? Okay. So our highest is 4 inches. Got a nice bell curve there. Very good. Okay. Let's see, do I close that, I guess? And let's see, go to next, come on. So I think the majority of you had it right. This is a typical recommended minimum ice thickness guide. This is put out by Minnesota Department of Natural Resources. And you can see that if it's 2 inches or less, not a good idea. I prefer this guide because, you never know when you might need your AT-AT to go across the ice, or if you're a Godzilla, it's good to know when you can actually get out on the ice. So anyway, that was fun. So that's the when we go out. This year we actually got a bit of a later start. As you all probably know, we had a kind of a warmer season start. So, but everything is good now. So where we went for 2018 through 2020, so the last 3 years, we've hit 8 different lakes so far in the greater Bridgeton area. And these are all in our service area lakes that we monitor regularly during the summer as well. We do every 2 weeks, we hit these. And when we go do these visits, we go to the same spots we go in the summer. And these are the deep hole locations on those lakes. All right, how do we do the work that we do? So we do some pretty basic tools. This is our ice auger, manual ice auger. We see a lot of fishermen with the powered augers, but we don't have to do that many holes per lake. So this does just fine. And it just gives us we just work through a 7-inch hole and do all our measurements and sampling, most of our measurements and sampling that way. Sometimes we need to remove the snow first, and we usually record how much snow is present or not. We then measure our ice and snow thickness, and this is a fairly basic gauge, a ruler. It's got a little extra on the end I'll show you in a second. And we measure that distance between the bottom of the ice and the top of the ice, but we also measure where the water level sits. And that varies through time, especially with the high snow load. We'll get water coming out of the hole. And right now at this time, well, now I guess it'll be a lot of pressure, but prior to this, our sampling, we've seen the water level just below the surface top of the ice. So there's a picture of it in the hole, and this should be a little video just showing using our underwater GoPro camera. So you get a sense of what the ice looks like. That top layer is very milky looking. That's because it's slush, potentially just from melt on top. Sometimes the water comes up and freezes on the top through a hole. The clearer ice has been where it's growing through time, and those little bubbles you see are dissolved gases that come out of solution during the freezing process. And sometimes there's gases that come up from the bottom as well, from microbial activity from the sediments. Then we use our multi-parameter sonde. Sonde is our sounding instrument. It's got a range of parameters that it can measure that are listed there in the middle. All in the one end of it. It also measures depth, so we can lower it and record all these readings at once at each depth that we stop. I'm just going to focus today on the temperature, dissolved oxygen or DO, and chlorophyll. And those are the basic water quality parameters that we do, that everyone here in Maine focuses on, and that we are also doing during the summer. So that we have to stand, or in this case here, Maggie is taking a breather and sitting on the ice. Fortunately, that coat is warm, and it was a beautiful warm day that day. And just get our readings with time, and I'll be showing you some of that data, so you'll see what that looks like. The device to the left is our peristaltic pump with marked tubing, and that's so we can pull up water samples from discrete depths for chemistry, biology. So the chemistry would be like phosphorus. We also can look at the algae or the chlorophyll in those discrete water depth samples. We have done a little bit of zooplankton sampling. Those are the little animals that are feeding on the algae. This is an intern that we had this past couple of years, Addie Caselli, and she was doing a project as an undergrad at USM. That was done during the summer, and she decided, wouldn't it be nice to come out on the lake and do it in winter and do the same kind of sampling? And she did. This was one of our coldest days, I think, as you can probably see. One of the things that was challenging is this is a bit of a bigger net than all of our other items, so we had to drill extra holes to get that net through. One of the things that we're only going out maybe a couple of times, 2 or 3 times in a season. To get that many lakes, it's a lot of work. And so you get these snapshots through time, but it's nice to be able to see a more continuous record of at least some data. And just like we do during the summer, we moor out strings or buoys that have a string of temperature loggers attached to them at various depths that record that data continuously throughout the summer season. And we are now doing it, we've done it on 3 lakes throughout the winter season. They get frozen in for the whole time. And that's an interesting data set that we've been kind of just starting to dig into now. So this is, I don't have a picture of that, but this is out of a publication on methods, on winter limnology methods, showing the various options of how you might freeze your buoy into the lake during winter. So now on to what did we find? So our ice thickness so far has been from 30 to 75 centimeters, or 30 inches roughly. We are currently, we haven't always gotten out as early, and this year our first measurements have been in the 20 centimeter range, so a little bit thinner. It hasn't had as long to build up. And here is, I apologize for showing data, but I think this is a good way to visualize it, the information. So I'll run you through this one. This is a plot of temperature, and this is on Keoka Lake in Waterford. And what I'm showing is depth below the ice. So we calculate our sonde measures pressure, so we have to do some corrections to get a distance below the bottom of the ice. And what you're seeing is temperature for four different dates in the one lake. The bluish ones are for winter, and the red is summertime in the same year. And I think you can see the difference that in what temperature stratification looks like summer to winter. So summertime, you have very warm temperatures in the surface, going down to what we call the thermocline, with a rapid change in temperature, going into cooler waters in the bottom. However, in wintertime, the pattern is reversed. We have very cold, the coldest temperatures are up near the ice, and the temperature warms up going as we go down towards the bottom. And one of the properties of water is that it's most dense at 4 degrees centigrade. So water, if you remember, water freezes at 0 degrees centigrade. And it is most dense at about 4 degrees centigrade. So that water sinks and settles towards the bottom. You'll find sometimes we see temperatures even greater than 4 degrees, and that might be due to warming from the sediments. The sediments actually hold heat in and warm up. And sometimes we never actually get to 4 degrees either, but you usually see this reverse or inverse stratification going on. Here's the record from that those buoy hobo strings, the thermistor strings that are deployed throughout the winter, just showing that we do have that inverse stratification going throughout the winter, but changing with time until starting in the fall, where everything's well mixed. Those temperatures are up and down, straight up and down, so everything's at the same temperature. You can see in December it starts to set up with the stratification, and it continues, and then it starts warming up in the spring and gradually mixes again in that later April or May. This is dissolved oxygen now, doing the same comparison in Keoka Lake between winter and summer. And you'll notice this time that the oxygen sort of has the same pattern of high levels in the surface layer going to low at the bottom, or anoxics, we'd say, when you get down to 0. And the blues, again, are winter. You'll notice that the wintertime levels are higher than the summer. And that's, again, a chemical property that colder water can hold more oxygen. So we have these saturated regions near the surface. It looks like we have a little bump in the July time. There was some production going on that might have generated a spike in oxygen. Here's chlorophyll. Chlorophyll, we don't see so much of a difference seasonally. Kind of surprising. In fact, there's a difference, but overall the profiles are fairly similar, except for this surface for the winter time. We have massive, in this case, for this lake, there were some massive blooms going on up right under the surface, right under the ice, and within the first meter or so. Whereas we did not see that in the summer, at least at July, and we had this more of a subsurface maximum of chlorophyll. This is fluorescence. It's not an exact measure of the amount of algae, but it's a good proxy for it, and it's what a lot of folks use. And we do see this, what is shown in July here for Keoka, also in the winter too. So it's quite variable, not quite the same, but it's showing us the change in depth with these biomass, these communities, algal communities. And they tend to, what we've seen a lot though is when there's a peak, it tends to be up near the surface. All right, now I'm going to run through a couple of where I put all 3 parameters together for one date in one pond, one lake. And we have chlorophyll, again, that's the fluorescence. The red is the oxygen, and the temperature is in blue. So again, you see that same inverse stratification of temperature and high oxygen up near the surface, decreasing, but still quite plenty of oxygen in this case. So that chlorophyll is nice and high in the surface. Here's what it looks like. pretty dense. And that you're looking at an algal bloom basically underwater. Now I've gone down a little deeper and you can see it's kind of starting to decrease a bit. You might even be able to see some little animals there. And this is the organism that we think made up a lot of that biomass. This is a chrysophyte, they call it, called Dinobrium. It's actually a what we call a mixotroph. It can feed multiple ways. So it can be an algae, it can photosynthesize, it uses light to get its nutrients or get its energy. But it can also utilize organic matter, it can eat like a bacteria would or a zooplankton would. So it's a unique critter, and that kind of makes sense for under ice communities to have these mixotrophs doing well because the light's kind of low, or at least it's lower than when there isn't ice. All right, here's another lake. This is Highland Lake in Bridgeton, and pattern's a bit different. You'll notice the temperature and oxygen looks kind of the same. The chlorophyll now, we do have a bit of a subsurface maximum in fluorescence, meaning that there was a population that was happier down here due to whether it's the nutrients available or the light available. That's where they were. And I'll show you what that looks like. I think immediately you can see there's a difference. Again, this is with a GoPro camera just on a selfie stick, dropping it through the hole. You'll see how those little animals, those little dots there, those are zooplankton, those are copepods. And those are the grazers that are feeding on at least some of the algae that are there. And that 5 meter at that little peak in chlorophyll, at least one of the dominant taxa that was there is this diatom. It's kind of algae that has a lot of silica in it, but it's called Asterianella. It's one of my favorites. It's so pretty, this star shape. It's very obvious when you see it, what it is. All right, here's Keoka Lake. Again, different, this is now 2020. The other data I was showing you was from 2019. There's a bit of a chlorophyll peak here. One of the things you should notice is that oxygen is almost down to zero, essentially zero. And that's really interesting to see. That means that there's microbial activity going on in those bottom waters using up the oxygen. So life is not dormant at all. It's cranking along quite well and very similar to what happens in the summer. And there's plenty of oxygen up here, maybe even a little peak, possibly due to photosynthesis by the chlorophyll or whatever's making up this chlorophyll signal. And I'll show you that. Again, you can really get a sense of the sort of thickness of it. Not quite as thick as that other one, but looks like I'm a little drunk there with the camera. It is hard to hold it steady. I have struggled with that. And you can see it disappears as we go down into the water column. That we think is made up of something called Cyanura. It's sort of like a chrysophyte, although they put it into its own category, but it's a colonial. I guess the Asterianella was too. Each of those arms was an individual cell. And here again, we have this, and the Dinobrium too was also colonial. I should have pointed that out. Each of those little cups was an individual cell. And they clump together, and this is the same idea. But one thing that isn't quite obvious from just the still picture is that it moves around, and you could catch, hopefully you can see on the screen that get a little bit of a sense. There's these flagella that stick out the end of the cell and propels this colony around. So they can move in the water column where they need to go, at least to some extent, and find an area of light that might be best for them. Oh, I should point out that the Cyanura is known to do well in low nutrient oligotrophic lakes. So not surprising for this area. And these are all common species that are common based on the work that we've done prior. I think this is the last one I showed, the profiles I'll show you is Bear Pond. It's one of our deeper lakes, an interesting pond because of that. And also, again, we have a bit of a peak in chlorophyll right near the ice, then declining very rapidly. We have same idea with oxygen, high in the surface, and again, going almost to zero at the bottom. But one of the things that's interesting that I pointed out before is that the temperature here, this is 5 degrees, so we're not quite, we're in the 3-degree range. So it's so deep that it must have taken a long time to freeze over. So it had time for the whole lake to cool down more than it usually does, than the lakes do. We found that the shallow lakes tend to be slightly warmer on the bottom. So we're seeing that effect going on here. And I will show you a bit of what that day looked like. And again, you can see some of those copepods. It's not, the algal layer isn't as obvious, although as you come up a little bit, there's definitely a lot of animal activity. So some of the organisms we saw in this, so from these samples were, this is another member of the algae. This is a dinoflagellate. Again, another organism that has these flagella that helps it move. These are also potentially mixotrophic. They can utilize organic matter as well as photosynthesize, depending on the species. Here's now getting to more of the animals. If I can get this going. This is a rotifer. So this is part of the zooplankton group. It's a little animal, and this is showing you what it does. And one of the things you'll notice, they have this corona of cilia around the top that is filtering, pulling in water and filtering it. And play that again because it's so fun. And they're pulling in those small algal cells and other particles to eat. And this is the copepod. I didn't have a movie of this, but you could actually see, it was amazing that we can see them on the videos. I find that fascinating. This is a couple of them. Fortunately, they get squashed under the slides of our microscope. This one on the right, it's got a whole brood pouch of eggs there. But it's clear there's quite a large community doing very well, at least in many of these samples that we see of the animals. So we have just started our 2021 monitoring, and we're going to be monitoring 11 lakes, including 7, I call them new. They're in our service area, but they're lakes that we haven't yet visited in wintertime. So that's exciting. And we're going to visit them, some of them 3 times in the season, some of them 2. So we'll collect, that's I think a total of 28 trips, assuming all goes well. We are also starting with a new instrument we have, which is a light sensor, PAR, photosynthetically active radiation. And that's shown in that inset picture. It's that little brass colored with a white dot sensor. So that measures the light that the algae use for photosynthesis. What we can use that for, as well as getting just absolute light levels and comparing, see here I am measuring it on top of the ice, and then I do the same thing through the hole underneath the ice to get a sense of how rapidly does the light go down as it goes through the ice. So obviously that depends on how much snow is there, the condition of the ice, is it all clear, is it a lot of slushy ice? And then we do a profile on down, and using that profile we can get a measure that's something like water clarity that folks who use Secchi discs get a measure of. They're somewhat related. It is a bit hard to do Secchi depth readings through the ice hole. We can do it. We're not so sure how good of those readings are because light is so low. We hope to do some some chemistry, some phosphorus measurements on some samples. Given time, we'll see how that goes. But anyway, we've started into it. We've done our first set. Just last Monday, we were out, Maggie and I. This is Maggie here, all properly masked up. And that's our sled of gear with all the gear that I've talked about. So we're excited to go on, and it's been a lot of fun telling you folks about it. And I think it's clear. I hope I've convinced you that these lakes during winter time are definitely active and productive. The communities that are there, you know, the fish, as I said, the fish need something a food source, and what we're have been looking at, is part of that food web that drives those communities, the whole lake ecosystem. And it's really interesting to get the physical and other chemical data to enhance our understanding of how lake ecosystems works, especially as we try to connect the data that we get in winter with what we get in summer. Is there any thought, well, there's thoughts that say a changing in our amount of time covered in ice can have an impact on the following season. Say, we might, if the ice goes out earlier, it might be that there's more time for the stratified period to set up, and therefore more chance for hypoxic conditions or anoxic conditions to set in, which has implications for phosphorus cycling and then into the following fall. So there's interesting connections, and we are trying to just kind of connect the dots. We've always had this warm season, and at least it's hard to get what they call the shoulder seasons when it's more dangerous to get out. But at least we're filling in some of the gaps in our knowledge during the wintertime. And of course, it is cool to do this work. It's a lot of fun. Here's just from our recent trip, showing you what the ice looks like. We did have quite a bit of rain and melt before we went out. You can see that sort of gray layer of ice on top that collected. So anyway, we're enjoying it, and I hope you've enjoyed hearing about it. And I want to leave you sort of where I started with the audio, a little bit of visual, but this is what I collected on Moose Pond. Beware, there's going to be maybe some loud noises. Hopefully you can hear it. I think that's a lot of fun. I'll play it again.
Good idea.
We were having a discussion about what to call those. The ice cracking and moving, I think, is what's going on. It's fascinating that we can hear it underwater, which I found really fun. This is the first time I've caught that on video. So there, I'll leave it there. And should I stop my share now, or?
Sure. Well, yeah, you can. We'll make your face bigger for your answers. Thank you so much, Ben. I think it's fascinating what's going on down there. The next time I go ice skating, I think I'm gonna just have to put my ear to the ice and peer down there and see what's happening. It's pretty amazing, and I think especially those sounds. And I think you should patent a name for those sounds.
I know. Maybe somebody has. I can't believe somebody has.
If anybody knows the official name of those sounds, let us know.
Yeah. I'm connected with a big winter group these days, so I'll have to post them.
Well, we did get a few questions that came in during the talk. One, somebody wanted to know if the ice thickness is the same across the lake, or and especially what about inlets and outlets, and is there anything that bodes for thicker or thinner ice?
To the first, definitely there's variation in thickness. We and they were spot on. It's, you know, especially where you have any kind of moving water, you can see open water. So it can range from thick to open water within the same body, within the same system. And it's just, I think it's that where you have motion or maybe high water input from a tributary. We were just on Peabody Pond, and we're a little dismayed. It made us a little nervous. We had a nice open water patch out close to our deep hole, and we're not sure why, but there was a tributary nearby, and it kind of appeared to be a channel or the remnants of a frozen channel that was leading to that open water. So now, the second part was, is there any, what?
Well, it's anything that's going to make the ice thicker in one area versus another, but I think you pretty much do that with the moving water. Someone wanted to know if you could recommend a portable microscope or digital microscope that works, particularly on the identification on the run. Ooh. Is a specific question.
I don't have any. I know there's some kits that allow you to use your cell phone. And there's, if you go to, I think it's the cyano.org, I think it is there's a citizen sort of science movement. EPA run is the one set it up, that focuses on monitoring for cyanobacteria, and they have some kits where you get a microscope. But I recall them talking about some ways where you can get a camera adapter to kind of magnify some images. Those might be good. Yeah, but otherwise I'm not, off the top of my head, I'd be hard pressed to come up with a name.
Okay. Will you be monitoring McQueen Pond in Waterford into 2021? Somebody wants to know.
It's one of our lakes. Okay. Who asked that?
Kevin Ryle.
Who?
Kevin Ryle.
Okay. Yes, we
will. And then somebody else asked, what other new lakes are you monitoring? What new lakes are you monitoring, and how do you select those new lakes that you do?
It was kind of where we could actually get some interest and support from some of the associations. So the new ones, we had done Sand Pond because I have a camp on it, so it was easy to go there and easy access. We're going to add Hancock Pond. We've added Peabody. We are doing McQueen. We're going to do a couple of the Five Keysers back and middle, Kai's Pond, and Moose Pond. I think that's all. So.
Okay. I got a few more. I'm going to we try to keep it to 45 minutes, and we know a little bit over, but there's some really good questions here. Okay. Does the heavy weight of trucks and snowmobiles on the ice affect underwater ecology, do you think?
I wouldn't think it would per se, unless they fall in. But it could. The only thing I can think of, there might be some effect of water level with lots of weight on it. Could change the water level slightly. But as far as the ecology being affected, I wouldn't think there would be much of an impact.
Okay.
Somebody.
Is there a certain depth under the ice where fish are unlikely to have enough oxygen or enough food?
Yeah, that's interesting. And I would love to sort of correlate with where the ice fishermen are finding I know some actually use some fish finders to see where they are. Excuse me, but I think the data we've collected, they definitely need oxygen. So in those bottom waters, they're unlikely to stick around when the oxygen is close to zero. So they're going to stay away from that. They have both a temperature and an oxygen optimum, and everything is definitely slower in the winter, but they're looking for that particular combination of place. But it looks like some of the food is certainly up near the surface. So we haven't been able to find discrete depths of where the zooplankton are. So for those planktivores of plankton feeding fish, the bigger fish are obviously going for where the smaller fish are, or maybe some crustaceans. So, but yes, there's definitely zones where they're gonna be preferred.
Okay. Somebody asked how far north you were, and so I should have mentioned you were out of Bridgeton.
Yeah.
Do you
Southwest.
how within Maine, would there be a dramatic difference in ice up north? I mean, I imagine it'd be thicker and last longer.
Yeah.
But anything you think in terms of the critters living under the ice that would change on a north-south?
On a gradient, yeah, that's a great question. And I wish I could say I have data to show it, to show you what, but I would definitely suspect, the communities, the under ice communities, or under the lake plankton communities definitely vary from lake to lake. And that's driven by the amount of nutrients available, some of the chemistry of the lake, how are they hard or soft water lakes, how much light is available, are they colored lakes, are they dark, from organic matter, stained. So all those things drive the algal communities that are there, and there's no reason why that shouldn't also impact them during the winter. So we would definitely expect to see variation. Now going on a north-south gradient, the community that shows up will be different depending on how long the ice is there, and that I would expect there to be a gradient of when ice is solid, and so when you have those winter conditions varies with space. So
yeah,
potentially could have an impact. I just don't have any data yet to be able to say that. Our region's so small, we wouldn't probably see huge north-south kind of big temperature gradients, but we do see some, and we do have colored. Woods Pond is quite colored. So
interesting. All right, I'm going to do one more question. There's some other great questions.
We can always write them down, or I can get to them later if you.
Yeah, we'll try to get some other questions, some of these other questions answered in on our website. Last year we made a promise to answer all the questions, and we're not making that promise.
We're not making a promise. Okay.
A little bit more time than we expected, but we will try to answer if you answered a question you really wanted it answered.
Okay.
My email is sgallo@lakes.me. If you want to email me the questions, I'll try to follow up. I'll end with one more. I know we're losing some people because we're getting close to our limit, but let me just ask quickly one interesting question, and this will be our last one. Can the zooplankton accumulation cause a temperature rise and potential ice melt if there's enough of it?
That's what a question. I don't believe so, but I will not say never. I'd say it'd have to be a lot to impact the temperature. The solar energy is the big driver of temperature changes. So I think that would outweigh it. So.
Okay. Well, I am sure we will. Thank you so much for presenting today. And I know we'll see you again because you're always doing great stuff over there. We love to work with Lakes Environmental Association. So
likewise.
Yeah, so for all our wonderful attendees today, you'll hear from Ben again one of these years. But thank you everybody so much for joining us, for the great questions, for the nice comments. It's nice to know. I did a shout out to all those people from far away, but of course we love our Mainers the most, and there's a lot of them on this call. So thank you everybody for joining us, and we'll see you in 2 weeks for Jeremy Deed's talk on Lake Cluster.
Good.
Thank you, Ben.
Thank you.